Hi, this is Ji Chengju. Today I will talk about the financial story rights. This is for the EEE598 demand response final project. First of all, it is the background introduction. So, what is energy storage system? Energy storage resources have the potential to act as a dominant role in electricity system. Energy storage is accomplished by devices to store energy to perform useful processes at a later time. It has several basic functions, such as peak load shaving, baseload power reduction, improving power quality, and backup power provision. As we can see in this picture, the energy storage system will charge when the load profile is low and discharge when the load profile is high. And we can also consider this as when the electricity price is low, we charge the energy storage system. And when the price is high, we release this energy. We discharge the energy storage system. As a result, it can realize the function mentioned above. The technologies of the energy storage system evolved from the traditionally pumped hydro to the most popular batteries and some new advanced technologies like flywheels, compressed air energy storage, thermal energy storage, even the superconducting magnetic energy storage, and a lot more. So, what's the benefits of energy storage system? It allows for intermittent energy resources to provide continuous power. That is to say, it make the renewable energy viable. And the energy storage system can serve as an ancillary service. It provides higher security and better power quality electricity. The energy storage system can also reduce energy cost because it can do price arbitrage between on-peak and off-peak hours. And it can also physically hedge price volatility. What does the physically hedge the price volatility mean? Because there are always some spikes in the low profile, the price profile. So when the price is suddenly changed very high, we can use a battery system to hedge the risk. And more importantly, it creates new market opportunities, such as financial story right. And now we have new question. What is financial story right? I want to explain something similar first. Financial transmission right, FTR. FTR is a pure financial instrument. FTRs are hedging mechanism. It has an incentive for investment in transmission. The FTR can redistribute the revenue. When the transmission line is congested, the congestion rents will pay for the FTRs. The formulations here are a typical model of FTR. The congestion rent equals to the LMP difference times the amount of FTR we purchase. The deviation of financial story right, FSR, is similar to FTR. FSR is a purely financial instrument. It will not influence storage system operation. FSR financially hedge against the price volatility. It will not only physically but also financially hedge against price uncertainty. The congestion related to energy storage system pays for the FSR. But we have two questions. Will the FSR redistribute revenue? And does the FSR create incentive for investment in storage system. So let's look at the model of financial storage rights. Well, the storage system can benefit from price arbitrage. Let's make analogies between storage and transmission. Both systems move power, but the storage system timely moves power, and the transmission system locationally moves power. So we can easily see the financial storage rights. It's defined similar to financial transmission rights. The purpose of financial storage rights are similar too. It hedge against price volatility, cover investment costs for storage owner, and redistribute surpluses. We only have a few literatures regarding the FSR, and I will show two of them. The first is Taylor's formulation, and we can see the sources below. The objective function of the Taylor's formulation is to minimize the system cost. And here we include a time variable. And in the constraints, we not only have the transmission constraints, but also we have the storage constraints. The storage constraints including the charging and the discharging capability, and also includes the maximum power that a storage device can charge. As we can see the equations, here we not only put in the constraints, but also have the due variables. In Taylor's model, he defines the financial storage rights as two components. One is the power capacity right, which corresponds to the congestion of the charging and discharging power, and the other one is the energy capacity rights that correspond to the energy capacity constraints. The financial storage rights in his model is the summation of power capacity right and the energy capacity right. The energy storage system can either act as a active storage, which can benefit from intertemporal price arbitrage, or act as a passive storage, and he can benefit from collecting of financial storage rights. As a result, in Taylor's model, FSR decoupling ownership and the operation, because the operation is by the system operator and ownership belongs to the financial storage system owner. The storage owner collect from right sales rather than participate in the market. In a simple word, the system operators such as ISO and RTO will operate the energy storage system, and the system owner can benefit from participating in the FSR market. To optimally utilize the storage system is a wise constructor. And let's look at Vitar's formulation. His objective function is different. You want to maximize the utilities revenue, and he built the formulations as shown in the slide. But here we still have some questions for the above two models. Firstly, the two models assume the energy storage owners will hand in their operation rights to the system operator. The storage owners should be able to participate in the real-time market. They can take advantage of intertemporal price arbitrage. And the FSR payments in the above two models is like only when the storage system is congested, they can be paid with the FSR. As a result, the energy storage system owner may have incentive to build a small storage so that the energy storage system may be easier to get congested. Now the question is, in which way the energy storage owner can benefit more? Should they transfer their operation rights to the system operator and get paid from FSR, or they should just do the intertemporal arbitrage? And this question is not answered in the previous literatures. In order to answer the question above, I built a revised FSR model to test the system. As we can see the formulations here, the objective function is still to minimize the cost with different time frames. The constraint includes the load balance in equation 12, the transmission constraint in equations 13 and 14, the storage device charge and discharge capability constraints in equation 15 and 16, the storage device capacity constraints in equation 17 and 18, and also the power production should be higher or equal than 0. This is a constraint in equation 19. And similar to Taylor's definition, the payments to FSR is defined with two components: the rents derived from charging and discharging constraints, and the rents derived from the capacity constraint. Let's look at the case study. I made two case studies. One is on 1 bus 2 period. The other one is on 2 bus 2 period system. And let's look at the case study 1, the 1 bus 2 period system. This is the typical 1 bus system. In the period 1, the load is at 100 megawatt. Period 2, the load is at 200 megawatt. The energy storage system has a power charge and discharge capacity of 30 megawatt and a energy capacity of 30 megawatt hour. The energy costs are different. It's varied from the energy consumption by steps. When the power consumption is smaller than 120 megawatt, the price per megawatt is $50. When the power consumption is between 120 and 140, the price per megawatt is $75. When the power consumption is higher than 140 megawatt, the price is $100 per megawatt hour. When ISO operates the energy storage system, we can see the calculation result is the storage congestion rent equals to $750. When the storage owner operates the energy storage system, the objective function is to maximize the owner's profit. As a result, the storage owner profits will become $1,000. Let's look at the comparison between the two scenarios. We can see if the energy storage owner operate themselves, they can earn more money than they hand in their operation rights. And let's look at the case study 2 with 2 buses and 2 periods. The models are similar, but the system have 2 buses with a transmission line. The generator's information are shown in the picture also. Unfortunately, the conclusions are similar as the 1 bus cases. The system cannot provide enough incentives for the energy storage owner to hand in their operation rights to ISO because they are earning less money. Let's look at the conclusions from the above case studies. Energy storage device owner may benefit more when they operate themselves rather than handing the operating rights to the system operator such as ISO and LTO. Actually, this will reduce the incentive of the storage owners to install more storage devices. And the story owner may more likely to keep their operation rights because they can earn more from price arbitrage. As a result, I propose two potential market scheme to provide the energy storage device owner to earn more money when they hand in their operation rights to the system operator, and create incentives to storage owner to construct more on the energy storage devices. The first potential market scheme is a contract. The contract is a possible solution that the energy storage devices owner may have a contract with the system operator so that the payment will be based on the storage congestion surpluses in their head market. And another potential market scheme is to include a storage fee. When the storage device is operated by system operator, a storage fees can be charged from the participants who benefit from the storage installation. The storage fees here is more like a lift to ensure the energy storage owner can benefit more than they operate themselves. Finally is the conclusion of this project. FSRs urge the separation of storage devices ownership and the rights of operation. System may have higher social welfare if the energy storage device owner transfer the operation rights to the system operators, but in current existing module, they are not able to do so. So I made two potential market scheme, and this need further discussion. In the current module, there may not be enough incentive for the owner to transfer the operation rights to the system operator because the owners may benefit more from the intertemporal price arbitrage. There are possible solutions are proposed to redistribute the revenue to have the energy storage facility owners to transfer the operation rights to the system operator and benefit from the FSRs. And the last part is a reference. I only have two references. One is from Taylor, the other is from Bitar. Thank you for watching.